Welcome to the Explainer. So, picture this. You're deep into your absolute favorite video game. You're sprinting through a level, dodging fire, and you need to know exactly how far away the bad guy is to land that perfect shot.
Have you ever actually stopped to think about how the game engine calculates that distance? I mean, it's doing it instantly, every single frame, no matter where you're moving. You might think it takes some insanely complex modern computer algorithm, right? Well, actually, scratch that. The core math powering all of that is a surprisingly simple formula you've probably known since middle school, the Pythagorean Theorem.
Let's kick things off with Section 1, Geometry You Can See. Okay, instead of just memorizing a bunch of boring letters from a textbook, let's actually bring this formula to life. Take a look at the right triangle here. If you were to draw physical, literal squares coming right off the two shorter sides, the legs, and then calculate their actual areas, something pretty amazing happens. The combined area of those two smaller squares perfectly, and I mean exactly, fills the area of the massive square attached to the longest side, the hypotenuse. So the real takeaway here is this beautifully simple equation. Area of A plus area of B equals area of C. But why does this work out so flawlessly? Well, it's because those two shorter sides are at a perfect right angle to each other. In math terms, we call that being orthogonal. Basically, moving horizontally along one leg has absolutely zero impact on your vertical movement along the other leg. They are entirely independent directions. Moving right along to Section 2, Real-World Right Triangles. It's time to level up. Let's pull this concept off flat paper geometry and use it to solve some actual physical problems you might run into out in the real world. Imagine this dilemma. You're completely locked out of your house. Total nightmare. The only open window is on the second floor, exactly 25 feet straight up. You run over to your neighbor to borrow a ladder, but, plot twist, there is a huge, thorny bush right at the base of your wall. That means the absolute closest you can safely place the base of the ladder is 10 feet out. So exactly how long does that ladder need to be to reach the window? Let's walk through the steps and solve this puzzle. First up, we need to identify our independent orthogonal legs. The horizontal distance out from the house is 10 feet, so A is 10. The vertical height straight up the wall is 25 feet, so B is 25. Next, we just square them. 10 times 10 gives us 100, 25 times 25 is 625. Add those two together, and you get 725. That number is our C squared. Finally, to find the actual length of the ladder, our missing hypotenuse, we just take the square root of 725. And just like that, by plugging these independent distances into our formula, the cheat code solves it. You're going to need a ladder that's just under 27 feet long. This perfectly illustrates how a piece of simple math powers so much of our daily lives. If you're building a 2D video game, you're using this constantly to find the distance between characters on screen. Or think about when you buy a TV. If it's advertised as a 15 by 19-inch screen, they're actually just giving you the diagonal measurement calculated using this exact formula. Your phone's GPS? It relies on this to find the shortest straight-line route across a map. Even construction workers use a variation of this, known as the 3-4-5 rule, to quickly verify that a room's foundations have perfect 90-degree corners.